Hello friends, this video on solid states part 2 is brought to you by examfear.com. No more fear from exam. Let's understand crystalline in details. So crystalline, it has large number of small crystals which are aligned to each other. So if you see, they have large number of small crystals, right? And they have definite geometrical shape. Right, all these crystals will have definite geometrical shape, and these all the constant particles, that is atoms, molecules, and ions, are ordered. You see, there's a good ordering here, correct? And it is generally long range order. For example, if you see, this is the order pattern here, and if you see, the same pattern will be for millions and millions of these crystals. So if you take this crystal, if you just increase the size of this, you keep viewing these crystals here, you'll see it has all similar patterns. It has long range order. It's a regular pattern. So what is long range order? Long range order is nothing but a regular pattern of arrangement. This is my long range order. And this regular pattern of arrangement which repeats over entire crystal. Please note, it has to be entire crystal. Regular pattern of arrangement of what? Constituent particles, and that repeats over entire crystal. Example can be this is my diamond, or we can get this is my NaCl. This is my quartz, graphite. There's so many examples actually, correct? So these are my crystalline things, and they have sharp melting points. So if you see here, if you take a particular crystalline substance, and this is the very key difference to find whether the substance is crystalline or amorphous or not. You take a particular crystalline substance, you heat this, keep heating this, and then you see that the temperature will increase. The temperature has to increase, and then you see that at one temperature, at a given sharp temperature, the whole of this, just observe here, the whole of this crystalline will melt. Correct? It's a very, very sharp melting point. At a given temperature, sharp means they have fixed melting point. For example, if you see, this has some X degrees Celsius, and X degrees Celsius, it will melt. This has some Y degrees Celsius, so you need Y degrees Celsius, it will melt. Even it is pure. They have very sharp melting point. Also, their cooling curve is a little different. If you see, if you keep this in this hot liquid you have, just remove the burner, it will start to get cool. And then as the time passes, if you see if you draw the time and temperature graph, you will see that temperature comes down over a period of time, and then it remains constant for some time, and again it goes down. And this is the time where it crystallizes. So actually at this time, the decrease in energy is not used for decreasing temperature, but it is used for crystallization. So this is the graph actually you get if you do this. Also they are anisotropic in nature. So when I say anisotropic, that means their physical properties, like electrical resistance and refractiveness, those kind of stuff, they show different values when it is measured across different direction. Same crystal. For example, in this case itself, you try to measure electrical conductivity in this direction. So if you try to measure in this direction, so you see, for an electron to conduct, it has to cross through so many electrons. But if you try to measure in this direction, it is crossing only 3 particles. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, so many particles, right? Also, if you, let's suppose, try to conduct in this direction, They are different, correct? Sometimes if you are drawing in this direction, only three other different particles you are crossing. So if you're talking about the electrical conductivity, or you're talking about the refractive index where the light has to pass, where something has to pass, that kind of property with the light or electrons, that property will differ because it is pretty much arranged, right? So if you're going in this direction, you're hitting three blue electrons. You're going in this direction, you're hitting three red electrons. Coming in this direction, you're hitting blue and red more. If you're going in this direction, you're hitting all the more electrons, right? So, and that's why their physical properties, such as I told, electrical resistance and the refractive index, they have different values when they measured across different directions for the same crystal. And this property is called anisotropic. So they are anisotropic in nature, right? Why? Because of the arrangement of particles in different directions is different. And please note, most of the solid matter we see is crystalline. Nature favors crystalline nature of solid. Nature favors crystalline. Why? See, crystalline is more about what? Symmetry and regular arrangement pattern, as I told here, this one, correct? So crystalline is all about symmetry. It's all about symmetry and regular arrangement of pattern. So nature always favors symmetry. For example, if you see the leaves, if you see the whole earth itself is all symmetrical, all square, right? Leaves, all human. If you divide the human in two parts, then you see from straight to bottom, you see it's all symmetrical. So nature favors symmetry, and thus nature favors crystalline. And all these solids we see, most are natural. So most of the natural solids we see are crystalline. Why? Because the nature favors symmetry. Correct? And why it is so? This is because, I mean, that is a very layman answer I gave, but from the chemical perspective, from the chemistry perspective, why nature favors chemistry is because the energy of the ordered arrangement is lower than that of irregular pattern. As I always told in the atom chapter also, it's all about energy. Everybody wants to be stable. Everybody wants to be stable. Whether it is you, me, atoms, molecules, everybody wants to be stable, right? The reason why you are studying chemistry is you want a good, decent life. You want stability in life. The reason why a particular substance reacts, for example, sodium react is because sodium reacts with chlorine to form NaCl, because sodium wants to be in Na plus form. It is more stable. So everybody wants to be stable. And so do the solids. Correct? That's how the nature is. And if you see, if it is regularly arranged, things are arranged properly. If it is regularly arranged, then the total energy of the ordered arrangement is lower than that of irregular arrangement. Correct? And that's why nature favors crystallinity. Hope you understand. The total energy is less. It is more stable. Total energy is less. I think we discussed about the crystalline energy earlier in some of the videos. We talked about that when you form crystals, the energy is released because the crystal is more stable, and it's difficult to break crystals also. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.